Okay, welcome to the new lesson on Python for data analysis. This week we will be looking at matrices and data frames. So by the end of this lesson, we should be able to create matrices, identify points in matrices, um, get subsets from matrices, perform some matrix operations. Then we will look at data frames and the difference between matrices and data frames. Again, we will also access data frame elements, extract records from data frames, add records to data frames, and then do some more manipulation on data frames. Okay, so let us begin. So we will begin here. So as you watch this, try to follow along, type along with me. So matrices. So a matrix is a rectangular array of numbers used a lot in mathematics and physics, and you will see this um, when you start working with neural networks and deep learning. Matrix multiplication is used there. But to create a simple matrix, we've already seen this before, but we will use NumPy. So let me first of all import the packages I need. So I'm going to import NumPy and pandas. And these are the two things I'm going to use to work with my matrices and data frames. So a matrix, to create a matrix, because a matrix is essentially a rectangular array of numbers, and it will have a certain number of rows and a certain number of columns. And NumPy arrays are used for that. So here I'm going to create a 3 by 3 matrix. So it will have 3 rows and 3 columns. So this is our matrix, 3 rows and 3 columns. And you can easily, if you need to figure out what the shape of the matrix is, just call matrix.shape and it will tell you 3 rows and 3 columns. If I had something like this, matrix 2, and add another row, add another row, just 10, 11, 12. Then I could print matrix2.shape. Okay, now closing parentheses. Does not match. Okay, there's a bracket missing. So now we have 4 rows and 3 columns. So you can see 4 rows and 3 columns. So a matrix is m by n elements. And in order to access elements in the matrix, we use the indexing. So we will type in m for the row we want and n for the column we want. In this case, say we want row 3 of the first matrix, this one. So we want row 3 and column 0, 1, 2. sorry, 0, 1, 2. We start indexing from 0. So row 0, 1, 2, which would be the third row, and then column 0, 1, 2, which would be the third column. So I will get 9. So this will give, that is this value there. Um, let's say matrix at row 0 and column 1. That should give us 2 because this is row 0, column 1. So that should give us 2. So this is how you create a matrix and how you access elements in the matrix. There are other array creation routines that you can look through if you're interested. So you can create a matrix with all ones. You can create a matrix with all zeros. You can create an empty matrix. You can create a matrix from existing data. So you can have a look at that later. Okay. So comparing a vector to a matrix. So a vector is or it has only one row, and you can, like we saw last week, um, use NumPy arrays to create your vector. So I'm just gonna say 3, 5, 7. So a vector has one row in it and then as many columns as possible, whereas a matrix would have rows and columns. Um, if you wanted to figure out the shape of the vector, dot shape, so that tells you 3 columns. You know, it's one dimensional, so um, there's no other value here. Okay, so now we can change. We have the matrices, or we have created a matrix or a few matrices. We can change the value in the matrix. So I'm going to create a copy, say matrix copy. Um, so matrix copy. So it is a copy of the first matrix we made. And now I'm going to change the value of the first row, first column. So first row would be this, first column. If we start counting from 0, first row, first column would be there. So I would say matrix copy of row 1, column 1 equals 99. So it should change from 5 to 99. So that has changed. So row 0, row 1, column 0, column 1. We've changed that. So now it is 99. So that's how you change the values. You can also get subsets from a matrix. And you can do that using slicing. So let's say we want to get the first row. We can say print first row, then I'm going to print matrix 0, and then I'm going to use the colon sign. So the colon sign takes everything. So we have taken the first row and then all the columns. So that's why we've ended up with 1, 2, and 3. Let's say we want the second column. We're going to say second column. So we will take all rows and the second column. So this is all rows, the second column. So that's from the original matrix, 2, 5, and 8, this second column. So that's what we will end up with. But we can also take out sub-matrices. So I'm going to call this top left 2 by 2 sub-matrix. And that we will take, so the sub-matrix would be 2 by 2. So we want 1, 2, and 4, 5. So we will go from 0 to 2. So it will take column 0 and column 1. And then, oh, sorry, row 0 and row 1. And then it will take column 0 and column 1. So we end up with 1, 2, 4, 5. And if we want the last two rows, say last two rows, that will be, so the last two rows, we're going to take row, we don't need row 0, so we'll take row 1 and row 2. So we'll take everything from row 1 to row 3. Row 3 is exclusive, if you recall from last week. And then we need all columns. So that would be the last two rows, 4, 5, 6, 7, 8, 9. And you can have a go at the let's say bottom right. Bottom right 2 by 2 matrix would be, so you can pause now and see if you get this. So the bottom right 2 by 2 matrix would be 5, 6, 8, 9. So 5, 6, 8, 9. So we will take columns, so rows 1 and 2. We skip row 0, go with row 1 or row 2. We skip column 0, go with column 1 and column 2. So we end up with 5, 6, 8, 9. Okay. So matrix operations, performing operations on matrices. So I will create two matrices, matrix A, np.array. First row would be 1, 2. Second row would be 3, 4. And then matrix B would be, let's say 5, 6, 7, 8. 5, 6 on the top row, 7, 8 on the bottom row. Gonna print matrix A. And print matrix B. So the first matrix 1, 2, 3, 4. Second 5, 6, 7, 8. So we can start with addition. You can matrix A plus matrix B, and that ends up element-wise addition. So 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, 4 plus 8 is 12. And you can subtract. And you end up with minus 4. 1 minus 5 is minus 4, 3 minus 7 is minus 4, and so on. Element-wise multiplication. So element-wise multiplication type in matrix A times matrix B, and again it goes 1 times 5, 2 times 6, 3 times 7, and then 4 times 8. So this is element-wise multiplication. With deep learning, you are likely, well, not likely, you are going to be doing matrix multiplication, which is a separate procedure. Matrix multiplication, matrix A, and we use the @ sign. So matrix multiplication is a very different thing. This is what you would use for training neural networks, other scientific applications. And you use the @ sign to perform matrix multiplication. You can also transpose a matrix. Matrix A, and we just call .t. So if we do that, you can see the rows have switched to columns. So this row 1, 2 has become the first column, and 3, 4, row 3, 4 has become the second column. So this is what transposing a matrix does. So these are the basics of using or working with matrices in Python. So have a go again, try to understand this. Is relatively simple. The slicing, if you've never come across it, might be tricky, but a little practice and you should be able to get it. Okay, so now we move on to data frames. And data frames are likely what we will be using, what you will be using in machine learning, a lot of machine learning applications. And we'll see why in a bit. So here, first of all, there is a difference between matrices and data frames. So I'm going to create a matrix using NumPy arrays. Um, 1, 2, first row, second row, 3, 4, and I need extra parentheses there. So I'm going to, yeah, let's matrix example. Now, if I try to do this, if I try to change this 2 to, say, a string uh, D, everything gets converted to a string. So you can see 1 becomes a string now, 3 is a string now, uh, this is a string now, 4 is no longer a number. So there can only be one data type, and here it's telling us the data type, which would be some form of string encoding. So there can only be one data type. There can only be one data type in a matrix. With a data frame, on the other hand, I'm just gonna say data frame example. With a data frame, you can have multiple different types. Um, so one way to create a data frame is to use the pd.dataframe function. So I'm gonna type this first and then explain. Let's put a list there. 1, 3. B, comma, 2, 4. Close my curly brackets, close my full brackets. So with a data frame, this is one way to create a data frame. You start with the column name. Maybe a better way of writing this is to say, but we'll see this, column 1 name, and those are the values in the first column, and then column 2 name, so the values in the second column. And there is so this is row 0 and row 1. And what we could do, again, let's say cat and elephant. So you are allowed in a data frame to have multiple data types. In your data frame. Okay. And this is useful for data analysis. A lot of the machine learning algorithms will work off data frames. So this is one way of creating a data frame, but we can also create data frames from vectors. Create a data frame from vectors. So let's say I have a data frame containing some or some vectors containing some information. First is a list. I've got some names in this list. So Alice, Bob, Charles, and Dakpo. And I have another list of their ages. So 25, 30, 35, and 28. And I have another list of the cities they live in. So Alice, well, the first one is Cork. Second is Galway. Third, Limerick. And the fourth, Sligo. Sligo City. Okay. So we have some vectors containing some information. Say they all correspond. So Alice is 25 and lives in Cork. Bob is 30 and lives in Galway. And we have all this information in lists. We can create a data frame from these lists. So we will start with, um, we can say our data frame. We can give it whatever name we like. df is, again, pd.dataframe command, curly brackets. I'm going to close my curly brackets and close my full brackets. Okay, then go inside. So I'm going to make a name, column name, and I'm going to say it takes the values from the names list or the names vector. And I have a column for ages and those ages. And I'm going to create another column for, let's say, city. City. Actually, this should be age. Name, age, city, cities. So this is our data frame now. Now you should be aware if for example, um, the lists weren't equal, you would get an error, weren't equal in length. So here there are 4 items. There are 4 items here. There are only 3 items. If you try to do this and they're not matched, you will get an error. Mixing dates, so all arrays must be of the same length. All arrays must be of the same length. That is your error. So let's go back here. So this is how you can create a data frame from vectors. Okay. So accessing data frame elements. Similar to um, NumPy matrices, we can also use slicing, or we can use the labels, the column names. So we'll go through this. Um, there are two main ways you can access elements. You can use .loc. Let me make this a comment. So .loc uses the labels associated with indices and columns. So let's see that. So let's go with df.loc, and I'm going to type in 1 and age. So what does that give me? So it gives me row 1 and the age column 30. So I end up with 30. The second way is to use the iloc, I-L-O-C, I-L-O-C, which uses numbers similar to matrix slicing, ing. So df.iloc, let's look for, let's say, row 2. What is row 2? And column 2. And that will give us limerick. So row 2 and column 2, that will give us limerick. So both of these ways of accessing elements are useful. Um, if you're interested in the age column, you can if you're interested in age column, as part of your program, you can directly specify the name of the column, or it might be helpful to just use numbers similar to matrix slicing, but they both work. So I could do, let's say, 1 and 1. They both give me 30. They both access the same thing. They're just accessed in different ways based on this function that you use, whichever function you use. Okay. So you can pause now and try to access, let's say, the name Alice. Okay, so here they are. You can use this and access the column using the name of the column, or you can use just numbers alone. Either way, you end up with the same thing. And which one you use will depend on your preference or your application. Okay. So now let us extract data from a data frame. So you can extract as a series, what is called a series object. Extract a column as a series object. Just call that df of, let's say, name. And you'll see that here. You can extract multiple columns. So I can call this um, let's say name and location. I'm just going to call it that. Df of, and then in here I put in a list the columns I want. So I want name and I want city. So, and you can see now we have extracted multiple columns. So you can subset, um, take subsets from your data frame. And notice here the inside the first set of brackets is another set of brackets with all the columns that you want, the names of the columns that you want. Okay. And you can extract a single row. I'll just ilock 0, and it just takes that row. Because if you look at the original data set, Alice 25 and Cork, that's the first row. If we wanted the second row, or yeah, and so on. Okay. In addition to this, you can add new records or new information to your data frame. So we're going to add a record. So new record. There are a few different ways. But we're going to go with this way. New record. So pd dot data frame. We're going to create a data frame that contains the new record that we want, and then we're going to join them together. So name, and in a list I'm going to, let's say Emma, because you recall when we created the first data frame, this is a list, and this is a list, and this is a list. So we're putting in a list here. Name Emma, gonna say age 27 and city Berlin. So now that I have my new record, I can join it to the original data frame. So here's what I'm going to do. I'm going to concatenate the two of them together. So df equals pd.concat, concatenate the two of them together. And if you need more help on the what all these functions are, you can go to this site, the pandas documentation, combining, comparing, joining, merging, all these other functions. Okay, so back to this. So pd.concat, we're going to concatenate the two. So the original data frame, df, on our new record, going to put that in a list, and ignore index, we're going to set that to true. And you recall this original index was 0 because it was its own data frame. But when we join them together and we ignore the indices, this now becomes 4. So you can add, this is one way of adding new records to your data frame. So this is a row. We added a new row or a new record. We can add a new column. So there are, if you want to add a new column, let's say add new column where all values are the same, df of country, um, Ireland, should be a string. So now you can see we've added a new column called country, and everything in this new column is the same. So we can also add a new column where the values are different, where the row values are different. So I'm going to say df of salary will be equal to 50,000, 60,000, 70,000, 55,000, 65,000. And so now we have a new column where the salaries are different and they all correspond. So you should be aware again, the number of items here should match the number of rows you have. Otherwise, you get an error. So if you're up for it, you can try, pause now and try to add a new column of your own and see what that gets you. Okay. So we've seen this. We can also we can do some interesting operations. So we can sort the data by columns. Sort the data in our data frame by columns. So let's say, for example, I'm just going to call this df sorted. And I want to sort by age. So I can type in df dot, and there is a sort values function in there, sort values. And I want to sort by age. So I will type in the age, the name of the column age. So df sorted. And so now we go by age. So 25, 27, 28, 30, and 35. What we could do is also maybe we want to sort in descending order because this is in ascending order. It's going from small to big, low to high. So I'm going to copy that, and then we will add the option ascending equals false. So now we are going from oldest to youngest. So in descending order, 35, 30, 28, 27, 25. So here you've seen we created um, a new data frame when we did the sorting, because I, at least here, I created a new data frame. What you can do if you want to sort, let's look at DF. DF originally, um, DF hasn't changed. So, but if we wanted to change, we can sort in place. So if we want to modify the original data frame, df.sort sort values, uh, age, and we will use this option in place equals true. So now you can see it has sorted um, the values. And if you want, you could try to re-index or renumber the rows if you wanted to. But I will leave that for another time. Okay. Okay. So selecting rows and columns. So let's say I want to select, for example, I have some data, I want to do some analysis. Let's say I want to select rows where the age is greater than 28. What I will do is subset my data frame, and I will so I want the data frame where the column age, I want rows in the data frame where the column age is greater than 28. And that gives me Bob and Charles. We can also select specific rows. So select rows 1, 2, 3, df of 1:4. So 4 is exclusive. And that will take row 1, row 2, and row 3, because we modified the original data frame when we used in place equals true. So it will take the first row, second row, and third row. Skip the 0th row, take Emma, Dakbo, and Bob. Okay. 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 So finally, let's look at combining two data frames. We've already seen when we added a new row, we essentially combined two data frames when we use this pd.concat. We had our original data frame and then this new data frame, and then we joined the two together. So df and our new record. So first of all, let's say df1 pd dot data frame, let's say name of some people, John, Jane, score, 85 and 92. So that's our first data frame. Second data frame, I'm just going to copy this, call this df2. Mike, Sarah, 65 and 42. Okay. So if I have a look at df1, that's one data frame. df2, that's a different data frame, and I can combine the two. Okay. So vertical combination. So combined vertical pd.concat. So we're going to concatenate the two, and in a list we put df1, df2, all the things we want to concatenate, and we're going to ignore the index. So we've combined them vertically. You could also combine horizontally. So let me create a new data frame. Let's call it df3. John, say Jane, Mike and Sarah. Scores were 85, 92. Actually, I don't need scores. I'm gonna go with age, 22, 23, 21, and 24. So df3. So this is df3. So I have John, Jane, Mike, and Sarah with score in one table, one data frame. John, Jane, Mike, and Sarah with their ages in a different data frame, and I want to join these two together. So I will use the pd.merge. So I'm going to say combine horizontal pd.merge, and then the data frames I want to merge. No, not the right one. Combined vertical along with df3, and I'm going to merge them on names because the name column is the same for both of them. So I'm going to merge on name. And if we have a look, so we have managed to join these two together. We merged on name. So this is where we will stop for this tutorial on matrices and data frames. For matrices, we use NumPy arrays, and when you get to, let's say, training a neural network or doing matrix specific operations, maybe when you use TensorFlow a bit, you will be using NumPy arrays. Um, for a lot of other um, predictive models, you'll be using data frames, so you'll get information in the form of data frames or in the form of CSV files that can be loaded into data frames. So there are some questions, and try to have a go at these before looking at the answers. Really, they're not difficult. Um, so you should be able to solve them with just a little bit of effort. So you will be given a diamonds.csv file, um, which has 53,940 rows and 10 columns. And these are what each column is. So the price, the carrots, the cut, and so on. So read in the diamonds data set using pandas. Display the first 5 rows. If you recall from last week, we used the head um, function. Display basic statistics. So mean, median, standard deviation. For example, here, for the mean, we could, if we wanted to find the mean age, let's say combine horizontal of age dot mean, that's 22.5. So this is one way of doing this. Um, Another way is to use the describe function, which will give you not only the mean, but also the maximum, the minimum, the interquartile range, the count. So number of rows in there is 4. And you can do this for the whole data set, the whole data frame. So it will do this for every column. So the mean score is 71, the max was 92, the minimum was 42. Okay. So display basic statistics for all numerical columns. Create a subset where the cut of the diamonds is premium. Create a subset where the price of the diamonds is between 300 and 1,000. Find out how many diamonds weigh more than 2 carats. What is the average price of a diamond? What is the average weight of a diamond? Create a new column called price per carat, where the value in that column would be the price divided by of the diamond divided by the carat, the weight of that diamond. And then you can sort the data frame by price in descending order. So have a go at this. Um, if you just spend a few minutes going through the examples I've seen, you should be able to do it. And then the answers will be on Moodle. Okay, so see you next time.